welcome back from the break, everybody, and welcome to the future of responsible artificial intelligence. We're going to have a great panel. My name is Shahram Tafazuli. I'm the founder and chief security officer of Forward Security. We're an application and cloud security company based out of Canada. And my background is in software development and security. I've been in the industry for about 25 years and very excited to moderate this panel. We've got some excellent guests. And maybe I'll get them to introduce themselves. Julianne, why don't we start with you?
Yeah, hello everybody. Very happy to be here in this panel. My name is Julien Billot. I'm the CEO of Scale AI. Scale AI is one of the 5 global innovation hubs created by the government of Canada with the support of government of Quebec. And our mandate, very simply, is to help AI adoption in the supply chain and industry. So basically what we do for a living is we fund projects. We pay expenses on projects that aim to introduce AI into supply chain activities or to support companies that are building AI products.
Excellent, excellent. Thank you for that introduction. Nidhi, please go ahead.
Hello, everyone. I'm Nicky Hegde. I'm an associate professor in the Department of Computing Science at the University of Alberta. I'm also a fellow at AMI, the Alberta Machine Intelligence Institute, and a Canada CFAR AI chair. I have a very varied background. I actually spent a lot of years in industry research, nearly 18 years, and most of that was in France. And I moved back to Canada 4 years ago, and I've transitioned to academia 2 years ago. So I have an outlook that's academic, but also with the practical in mind. And my focus recently has been on privacy and fairness in machine learning.
Excellent, excellent. We have lots to talk about probably offline, but thank you for that introduction. Bridget, go ahead, please.
Hi, thank you for the invitation to be here. My name is Brigitte Nollet. I'm the incoming president and CEO of Hoffmann La Roche Canada, which is a pharmaceutical company. I represent the pharmaceutical division here in Canada. I would say Roche is at the forefront of innovation and biotechnology worldwide. And here in Canada, really proud to be at the forefront of health and artificial intelligence in Canada. We have a Roche Center of Excellence in AI, really working in partnership with different Canadian research institutes. And I think for Shad, in terms of introductions, what I wanted to just lay out is this is a really exciting time to be in the life sciences sector, to be in research and development. At the same time, we're also seeing our healthcare system really overburdened coming out of COVID and really at that crossroads in terms of its sustainability into the future. And so that's where AI comes into healthcare. And I'm really happy to represent, or at least offer my perspective and the company's perspective in terms of where that benefit can meet and how do we help patients with stronger outcomes? How do we help healthcare practitioners? How do we help with better R&D? And how do we work with our partners and our government partners to think about the regulatory and policy pathways that we have to start thinking about in advance, given all this amazing science that's coming, and how might we make it available? And just by way of background, I spent the last 9 years in global roles and in European roles. So I'm also happy in the context of our conversations to offer some perspectives of what I'm seeing in other parts of the world as well, because I think Canada has huge talent, as we heard from our previous speaker, and yet at the same time, we're not the only country that's moving in this space and that's competing for this space. So I just think it's important for us to keep that in mind as well. Thank you for the opportunity.
Absolutely, Bridget. Yeah, no, I worked in a global role for 10 years prior to starting my company, and it's absolutely important to bring that view to Canada and help our companies in this country do better and compete at that international level. Thank you for that. Shahram, go ahead, please.
Yes. Yeah, hello everyone. I'm Shahram Tafazuli. I'm the CEO and founder of Motion Metrics International Corp, a previously privately held venture that I started 25 years ago and bootstrapped, never raised any money. And December 1, 2021 was sold to an industrial giant, Weir, in the mining sector for a headline price of $250 million. And excited to be here. My background is electrical and computer engineering. I got my undergrad and master's degree from Sharif University in Iran and my PhD from University of British Columbia. What we do at Motion Metrics, since 25 years ago, which I was starting as just imagine me with no gray hair, very young, fresh graduate of university, was to look at the tough challenges originally in construction and then mining industry and see how we can use sensors, cameras, embedded computing. There wasn't really much cloud computing back then to make them safer. And then in 2014, the business advisor of Motion Metrics is the founder of Creative Destruction Lab, Professor Ajay Agrawal. He made a very huge suggestion that made a big difference in the company, and said he's seeing ventures in technology who are adopting AI for tough machine vision problems and image processing. And he recommended Shahram look into this because this is what you are doing and the challenges are there. So hired the first consultant, and then after a year seeing amazing results, we really became an AI, a combination of AI and 2D, 3D machine vision to address tough mining challenges. I kind of resonate Bridget's comment that it's exciting times also in the mining industry. It may sound boring, but it is a multi-discipline industry. And really, for many years, I don't have background in mining. We were becoming famous in mining for non-mining engineers addressing tough mining challenges using technology. And we are in Canada, where there is a big mining country. Sustainability is so important, and we are making a play on that in the coming years. And also AI was really, when you look at the deep learning, was born in Canada. So we have those three intersections, and I will talk more about that as we move in the panel discussion. Excited to be here. Thank you, Farsha.
So thank you for that introduction, Shahram. Really appreciate it. Let's start, since this is a panel on future of AI, let's start by level setting on what artificial intelligence is and what are the different types. Perhaps not everyone in the audience is familiar with that. And Nidhi, maybe I'll start by asking you if you'd like to elaborate. What is AI and what are the different types?
Sure. AI is actually an umbrella of things. It includes many different techniques, methods, algorithms that fall under the general umbrella of AI. And when you go into a little further detail, it's broken down into many different things. AI could include, for example, robotics, training robots to be autonomous, moving around a warehouse, for instance. It also includes, a large area of machine learning where you're, learning models from data to be able to predict and infer, which is, quite different from robots, which want to move around, themselves. And in machine learning, there are a lot of different ideas. There's something called supervised learning, where you have a data set and you're learning from that data set, a model, which then you're using to predict or infer on new data points. There's unsupervised learning, where you have a data set, but you don't really have labels, like you don't know what those data points actually refer to. And there you might do things like clustering, putting the data points in different communities and different groups, and then using that then to make other inferences on new data points. And then there's something called reinforcement learning, which is likely of all three types of machine learning is probably the one that's gaining a lot of interest these days. And it's actually the specialty of researchers in the University of Alberta. Yeah. And reinforcement learning is where you're sort of learning from your environment. You're taking an action, your algorithm or your policy is taking an action, looking at what effect it has, and then learning from that whether that action was a good action for that particular environment or not, and so on. So your actions are reinforced by some sort of feedback. And from that, you learn a policy, which hopefully is optimal for that scenario. So those generally, are the different types of algorithms, techniques, technologies that fall in that large umbrella of artificial intelligence.
The one question that I keep hearing from people is, what's the difference between AI and ML? And apparently they're different, but there's a nuance there. Would you mind elaborating on that?
Yeah, there is a difference and there's a nuance. So machine learning is really about learning a policy or learning a model, a predictor from data or from the environment. And AI includes machine learning, but also other things like self-driving cars, which, our AI in general, they may have little machine learning algorithms in them, but in general, they're about, having this machine or system be able to notice things, detect things, act on it, and so on. So that larger part is AI. So, robotics, for instance, creating robots that move around the warehouse, picking up packages or whatever, that might fall under AI because it's this large system that, has a more general objective. Right. And within that, you might have little techniques that rely on machine learning. For example, this robot's going to go around, and the way it's going to see if that's the package it wants, it might be using some computer vision technique, or it might be using some other machine learning technique.
Which still falls under AI, but it's not ML.
Exactly.
I don't want to date myself, but I graduated from UBC also in the 90s, late 90s. And at the time, our extent of AI was expert systems. And that's what we learned was, hey, expert systems. Yes. I can't remember what language we used to program, and we had a bunch of labs in that, but things have come a long way since then in the last, for sure. And I guess my next question is, so, we thank you for Nicky for letting us know about the different types and what AI is. But what I want to know is, what is the purpose of it and how is it used today? What is it used for today? And Bridget, maybe I'll pose that question to you if you wouldn't mind.
Yeah, thank you. Do you know what, Farshad? I still remember getting my first email address in the 1990s at university. Right? So, this is a long movement from there. And even when I think of the science, right? Cell therapy, gene therapy, the things we're seeing coming, immunotherapy and cancer, and AI and research is a part of that. And I think for me, there's maybe 4 areas to focus in on in terms of how AI can really support healthcare. And I say support, it's back to this concept of enabling. Ultimately, the healthcare practitioners, government, companies it's still humans making the decision within healthcare. I think that's really important. Yet AI is a big enabler. And for the simpleton in me, I was at a dinner a few weeks ago and a person described it to me as AI really is the electricity that runs through the systems and helps us understand, helps us turn the lights on and the light bulbs on, and helps us appreciate where we need to go. So in healthcare, I think we can think of, first we have to think of AI as a partner to health data. I think we heard that from our previous speaker. There's a lot of important information in healthcare that is collected, and it's how we understand the framework for health data. And then in our space, Nicky, I think for us, it's a lot about the algorithms that we use in the background to help us then understand the information and bring insights to the forefront where we can make decisions. So one area would be in healthcare sustainability. How do our government partners understand the information, understand if the investments went to the right places, if we got the outcomes we were intending, right? The pandemic was a good example. We invested in certain places. Did we get the results we needed? Had we had some faster warning signals or faster information, would we have been able to pivot some of the investment or some of the public health decisions? So I think it could be a real enabler within healthcare sustainability. The second has to do with research and development. So for companies like mine, how do we understand where we can be much more precise with our research question and really help us, help our university research partners, help our small biotechs in Canada? How can we think of AI to help us within the right algorithms within our research and development, and then bring new technologies and new medicines forward, which ultimately would be the goal. The third is, how do we help with the decision-making that healthcare practitioners need to make, right? If we can use AI in a way that can work through the data and help them make good clinical decisions for their patients, they're going to be able to spend more time with their patients. We're going to get better patient outcomes, and we're going to reduce the burden that we have seen, unfortunately, in the past few years on our healthcare practitioners, be they nurses, pharmacists, physicians. So I really think that AI can have a positive, coupled with the right health data, and we can come back to that if you like. I think that there's a real positive attribute that we can look forward to.
You bring up a really good point, Bridget, in that sense that I know that in the past, family and friends have been impacted by certain diseases, and the doctors haven't been able to recognize what's wrong. Had machine learning and AI been involved and they'd looked at large data sets, they would have noticed that there are anomalies and other instances of that happening and be able to diagnose better and address those situations.
Exactly.
So I think it's some really good applications in healthcare. Would any of the other panelists would like to comment on the applications and what it's used for today? Julianne, go ahead, please.
Yeah, well, I think what both Brigitte and Lily said is of course very, very strong, because what AI basically, it's a set of tools to do basically two different things. One, to give better prediction, and to give more insights to decide. And so you can apply that to a bunch of things and very large operation. At Scale AI, what we do is we fund projects on supply chain, but supply chain is very broad activity. And the reality is AI technologies are used for a great variety of things. It can be demand forecasting, how to forecast and to predict demand, also to adjust pricing, because that has an impact on your supply chain. You can use it to optimize and trace all the products going on your supply chain. You can use it in your data in your warehouses. You can use it to pilot robots in your warehouses. So you can really use AI all across the supply chain. And the reason to that is supply chain today are providing a lot of data, and you can use tools to help at every step. People and humans actually decide what they should do about all this data and how they could improve the way to optimize their supply chain, their activity. Typically, if you think about a big factory, we funded a project for Kruger, building a paper factory in Sherbrooke. And basically, they created a digital twin for this factory. And what they can do with AI is much better predict all the maintenance and all the issues around the factory itself. And so it allows them basically to predict or to think about predictive maintenance before the issues really happen. And so it was so efficient, actually, they decided to increase the size of their factory, because that's really providing much better insight. So what you said about prediction, prescription, actually can apply to a variety of things. Data obviously is key to do it, but you can apply that to a variety of industry. If I can take another example in health, we have funded a project for Roche, actually, during COVID, for testing availability, meaning the big question for Roche was, well, a lot of testing were available, but not enough for the critical people. So how do we focus this, and how do we put the testing products at the right places to maximize efficiency? So AI can really be applied on a lot of verticals and a lot of use cases, definitely.
Julian, thank you so much. Shahram, would you like to say something on that? Go ahead, please.
Sure. I'll build on what Nicky, as she explained, the AI and machine learning being a subset, and then deep learning being a subset of machine learning. Really, in the case of motion metrics, for many years, until 2014, we were using standard image processing. So we were putting these cameras or large mining machines to look at the bucket and say if everything is intact. You know, the teeth in the bucket, which are about 200 pounds hard metal each, they are wearing out slowly, but sometimes they come loose because you are digging hard material. If they come loose, they can cause big problems, safety concerns, and you know, people have been injured trying to fix a crusher which a tooth has got stuck with like hundreds of tons of material on it. So we were trying to solve that before. And then we noticed how difficult the problem is. You have to do it fast, you have to do it accurately, you don't want to have false alarms telling the operator there's something wrong and it's nothing wrong. So we challenged, and we got to, you know, better than 5% false alarm rate accuracy. And so much so that the mines were, you know, buying into our systems. But once we started using, you know, data labeling. So just imagine images of buckets, rocks, delineating the rocks. We had, you know, humans labeling these set of essentially practically thousands of images and videos, and doing computer convolutional neural networks, CNN, and so forth. We saw the amazing result. We had a product that we were almost getting disappointed. We cannot get, because the amount of time you see the bucket of a loader is like less than a second during each, and you don't know where it is. AI completely within 6 months of development, it really changed that. And it made us realize, wow, this is powerful. That was 2015, which I announced, okay, everything we are doing is gonna be now AI based. So excited, and then ever since we have been expanding on that. So use AI to predict, as Julian was saying, you predict what are the rock sizes so that you can optimize mining, because believe it or not, 4% of the world electrical energy today is used to reduce rock sizes from meters to powder, so you process that. And we are trying to reduce that impact on the planet by measuring it and telling the mine insights and judgment. How do you improve on that? So lots of exciting work we are doing in our own vertical. Thanks, Farsha.
That's amazing. That's a fantastic. 4% is a lot. If that can be reduced, that's a huge benefit to our planet. That's fantastic. I guess the next question that's on my mind and probably on the audience's mind is the biases, right? I keep hearing this about, AI can be good, but then there's biases, and depending on who set it up, it could do good or bad. I also want to remind the audience that you can ask questions. Please post your questions at any time, and then I'll present it to our wonderful panelists here. So Nidhi, do you want to talk about that? Well, maybe we'll start with you. What do we do about the AI biases in AI?
Yeah, so let me first explain what that means. What the bias in AI means is it's really about fairness or bias with respect to certain groups, subgroups. And these are really demographic features. So for instance, you may have a demographic type of race or demographic type of gender or age. And then within that, you have multiple classes, you have multiple types of gender, multiple classes of race. And when we talk about biases or unfairness, it's that the outcome is not equivalent between the different subgroups of a demographic. And one famous example is a predictive policing algorithm that was used in the US for deciding on bail or sentencing, where they used a classification algorithm. And it turned out when they looked at when a investigative journal such as ProPublica looked into this, they found that Black males were unfairly given a higher rate of recidivism than white males. And that was then used, that risk score was then used to decide on bail or sentencing. So that's an example of unfairness or bias, where and the source of this bias or unfairness can be hard to track. In that particular case, there can be multiple sources. In that particular case, one source of bias would be the data, because the data was arrest data. So it was data collected on who was arrested. So there might have been bias already in who was arrested. So the data was probably already biased. And if the algorithm is not, taking that into account or doing something specific to mitigate the bias, then those outcomes will then be biased. Or if the algorithm is somehow, the model in training is somehow learning a correlation between the demographic feature and something else that really should not be there, then that is reflected in the outcome of the algorithm. Right. So that's bias. And there are many researchers thinking about how to, mitigate this or correct this. I do want to say that, we don't necessarily want to completely erase the demographic features because first of all, that does not generally eliminate bias, because it could be, there might be proxy features. For instance, if you're looking at the home address of somebody, that might be a proxy feature for many other things. And secondly, it's actually important in many applications, a demographic feature, such as healthcare, for instance. There might be certain demographics for whom a disease presents differently. So you don't necessarily want to erase the demographic features, but you do want to be careful that, the advantage and the disadvantage are sort of distributed evenly.
Right. Thank you for that. Would anybody else like to comment on that? I have a kind of a question related to that. And you mentioned, Nidhi, that bias is related to mostly to the personal side of things. Would bias also be applied to just, I guess what I'm wondering is, the system is as good as the data that you feed it. So if I'm feeding the data, I'm biased towards feeding a certain type of data. So the outcome will be based on the data that I feed it, versus if you started a system, you would feed it data that would have your view. So then there'll be biases even beyond the people or the race characteristic type situations. It'd be biased towards certain outcomes based on the input that has been fed, right? Ultimately, if you don't want any bias, it has to be fed by a broad range of data points and coming from different backgrounds, whether it's people related or otherwise. Again, I'm not an expert in this, but that's some of the stuff that I've heard with respect to biases. I don't know if that's correct or not.
Definitely, if data is, biased, it's going to be reflected in the outcome of the algorithm. That's definitely true. But there are cases where even when there has been an effort to debias the data or balance the data,
right? That's what I was trying to say.
There might be bias reflected anyway. And one example is, a study that researchers Joy Wolamwini and Timnit Gebru did called Gender Shades, where they took image data of faces and fed it into off-the-shelf classification algorithms. They were gender classification algorithms, for instance. And the data was imbalanced in the sense that there were more faces of Caucasian or white people in it than Black. So they balanced the data set by adding or, oversampling the Black faces. But they saw that even with the balanced data, there was still bias in how the classification algorithm worked.
Wow.
So, and that's specific to image data, right? So it really depends on how the image is captured, how the image is represented in the model and so on. So there are a lot of steps in that pipeline where you could, inject bias.
Shahram, you had your hand up. Go ahead, please.
Very quickly, talking about the biases, let me bring another angle to it. So just imagine a camera is looking at the scene of the rocks. This could be on the face of the mine, inside the shovel bucket, on the truck that is carrying it, or on the conveyor belt as it gets smaller. So what we saw initially that as we were coming up with the algorithms to, we have humans going and delineating each of the rocks. It will take 4 hours for a big image, high resolution to be done. So in AI, now we are doing it in less than a second with better accuracy. But what we noticed that if we are feeding too much big rocks, so we have tendency toward the bigger rocks in the segmentation. If you are feeding more of the fines, there's tendency to the fines. Or let's say fines are usually darker. So even if you have a large rock, but it's darker, the algorithm thought, oh, this is a fine rock. So it took us a couple of years and lots of training data. That's one good thing about AI, is that in the old days, you had to go to beg to the group of engineers, can you come up with a better algorithm that's gonna work? In the age of AI is essentially, oh, it's not working as well. Is the network good? If the network is good, let's feed it new data. Within a week, we tell our customers, oh, we have an updated software for you, and it performs better. And I love that. That's a kind of paradigm change for us. So we have seen bias in terms of the rock segmentation, which we are trying to do to improve mining. And it took us a few years to overcome that. And also bias in, is this rock on the face of the mine, inside the shovel, is on the conveyor belt, everywhere is different. So that's our angle on the bias. Thanks.
Shahram, so is that a product of big data and machine learning that's sort of been on the rise in the last 10 years?
Yes, indeed. So we are making, is a paradigm change. So to the point that Julian was making earlier, is prediction. We are nailing prediction in terms of knowing the rock sizes accurately, timely, everywhere. So now what do we do with it? So we want to improve sustainability. We want to prevent the problems and all that. Some of that doesn't exist in our industry. But some of them, for example, in the financial markets, banks know if you improve prediction, they know what to do with it, because the whole infrastructure, the two problems are isolated. In our industry, they are not isolated. So it's a paradigm change, and we have to get the mining company to buy into our new approach of doing things. Thanks.
Sounds good. Bridget, you had your hand up as well. I'd like to pass that over to you.
Sure. I just didn't want to lengthen the conversation too much if you had other questions, but I think that Nidhi answered it really nicely in terms of bias. And in the healthcare space, sometimes you are looking for a little bit more, or maybe the question I should be asking Nidhi is, when you're doing research and development and you're looking for a specific subpopulation that is really aiming towards that same tumor type or that same disease area, you are looking for a specific bias. So there are moments where it's important. And then I think she gave some excellent examples where you might be looking at clinical decision support, like we talked about earlier. There you want to make sure that you are getting all of the right information, and AI is helping you then surf through it to make the right decision for your patient. And there you wouldn't want to see, or what you might end up with is information that tells you this particular type of population might be suffering more from this particular ailment, but you'd want to start with more neutral, a neutral base versus a research question where you might be starting with a very specific subpopulation already. So there are moments where bias has a positive, and maybe in some places where we have to be more careful. And I think that's why for us in the healthcare space, while I totally agree AI has been with us for a long time, where I think we need to keep going is working with our government partners and experts like Nicky to understand how is it that we could bring forward the right regulatory discussions, the right ethical discussions, the right policy discussions, so that when companies like ours or our industry in the life sciences brings forward these healthcare solutions, we're not starting the conversation on the background at that point. We've already laid out the right framework that we should be working in so that we can bring these solutions forward faster in the future. That's a big ask, I think, on our end.
Absolutely. Nicky, you wanted to respond to that? You have your hand up.
Yeah. First of all, I do think that Brigitte raised a good point about regulatory and policy frameworks. But just going back to her point about, different demographics in the healthcare data. For one case, one example, for instance, that we're working on is when you have healthcare data that's in different jurisdictions or in different hospitals, different areas that cannot be shared because of security, privacy constraints. We're trying to develop, for instance, a method of synthetically generating data that looks like the data, but is still private. And when you do that, you also want to take care to make sure that the different demographics are represented correctly in that synthetic data that you've generated. Right. So yeah, so this is another case where you do want to pay attention to, bias or the different demographic features.
Julien, you wanted to respond to that as well.
Yeah, no, I just want to highlight the fact that we should not look at AI only and targeting human activities or activities for human, meaning there's a lot of application AI that are purely industry driven. Typically, we have funded a project with Optel, and what Optel is doing traceability for the aluminum industry. So it's just to be sure that when Canada is shipping aluminum to the US, it's really Canadian aluminum and not an aluminum from Russia or another country, just labeled Canada to go through. So in that case, meaning the human bias are not existing. So for sure, human bias is a very critical issue. But you have also AI applied to a bunch of activities that are not involving AI, having human biases. And so which are causing less critical ethics, I would say, issues. And I was talking about maintenance, traceability, all this type of thing are really AI applied to raw data based on processes, business processes that are not involving at any time human or bias on this one. So just to not to be too much human based on this one.
Right.
Try to mitigate that.
Excellent. I'm going to go to some of the questions here from the audience. First question I have here is the panel and the previous speaker have spoken about the importance of keeping bias out of AI, but given that the algorithms in use now, such as ANN, do not allow for explainability, how do you keep bias out if you can't trace it? Who'd like to take that question from the panel?
I can start with that. So explainability is where is when you want to try to explain why you have an outcome that you do. And you don't necessarily need explainability to be able to detect whether there has been bias or unfairness. For instance, you can look at outcomes from, for example, if it's a classification algorithm, you can just look at the outcomes from that classification algorithm. You can look at the various metrics, for example, accuracy. Do you have the same level of accuracy for the different subgroups? Do you have the same level of false positive rates or false negative rates? Depending on the application, one is more important than the other. Is that roughly equally distributed? So there are metrics from the output of an algorithm that you can look at to discern whether there has been bias or not. Now, explainability certainly is a good piece that can help you. For example, if you're able to explain why a certain outcome is given, and if that explanation includes a demographic feature in it, then obviously there has been some sort of bias where a demographic feature has resulted in that outcome, right? But you don't necessarily need the explainability piece. You can just look at the metrics.
Excellent. Thank you for that. Any other panelists would like to comment on that question? Okay, we'll go to the next one. I have another question. It says, is there any work on safeguards for failure of AI and prediction of important things like health metrics? Hope that makes sense. As an average person, I think I'm mostly worried about is reliance in this technology. Bridget, do you want to take a stab at that?
Yeah, certainly. I mean, I guess we shouldn't, I appreciate the question because we should not look at AI for AI's sake. AI is an enabler to help us make stronger decisions in healthcare. That's ultimately what we're trying to do. And depending on the type of situation you're in, so if you're in a clinical care decision, I presume the information that we're looking for, at least in some of the work that I've seen, for example, out of St. Mike's, with Dr. Mandani, it is really looking at prediction. It's looking at clinical information that's coming in to the ICUs. It's being able to understand where patients are at, where their vitals are at, and helping prevent heart attacks. So when the vitals start to move, the healthcare practitioner is immediately informed and they're able to intervene and save a worse outcome for that person, right? So it's that prediction we've been talking about. And I think that's really important. When it comes to research and development, there is a whole framework. It's really about the secondary use of health data. It's not the primary use that's necessary. It's that aggregated information. And there are safeguards in healthcare around how that information should be pulled together. We're learning a lot about that out of Europe with the European health data space. How do we put together with GDPR that was referenced earlier, the right framework so that that secondary information can then be shared so that governments can make the right decisions, so that researchers can target the right questions. And so hopefully that's a good starting point in terms of there are important situations and algorithms and safeguards put into place. I think that's also why the Pan-Canadian strategy on health data is so important. It's also why the Pan-Canadian strategy on AI is important, and that continuing to have that dialogue so that we're really looking at these technologies, these enhancements to support healthcare, not to over-rely on it or take it over. Those elements are important for us to talk through.
Absolutely. Absolutely. Thank you, Bridget. And Shahram, would you like to add a couple of words about that?
Just very quickly to add, I really like this question, by the way, but I want to make a case for the opposite of that. I was listening to this interview with Vinod Khosla, and who is a major investor in AI technologies. And he was making a case that roughly 10 years from now, it may become almost criminal for a radiologist, human, judging the person's health based on the images, because AI, just let's face it, we call a doctor, as I was growing up, say he's a good doctor, she's a good doctor. It usually tons of experience, has seen many cases, and can make that judgment. And really now you have an algorithm that is being trained on by huge number of researchers on a huge set of data that really impossible for any human to be able to have seen that and make the judgment. So there's that case. And also in our industry and the mining industry, we are getting to some stages that I look at the image, I can't tell if a tooth is missing or if a piece of the bucket is gone, but the algorithm is saying it's gone. And then we go digging deeper, we look at the image and say, oh, the algorithm is right. As a human, I couldn't guess that, and now it's getting there. So just wanted to make that point.
Should it be an enabler, like in the case I used, that the doctor making this, or the radiologist, right? Should it be that the AI should make the decision, or be a combination where the AI presents the decision and then the human looks at that decision, takes it into account, and makes the final decision?
My personal answer to that is a transition. So it will take some time. The same thing I saw in the motion metrics, right? It took about 5 years for AIs or the prediction aspect. We are very early in the insight and judgment, I would say. But on the prediction, it took us a number of years, and labeling data and getting there. And I think the same thing is happening, but there's a huge amount of activity on that. And let Nidhi answer, and she's an expert in the area as well.
Nidhi, you have your hand up, so you might as well go ahead, please.
Yeah, I think with regards to your second question there, Farshad, I think it really depends on the scenario and the context you're looking at. I don't think there's one answer for every context where AI is used. So for instance, if you're thinking about like the radiologist example, you don't want an AI algorithm to replace the radiologist, because the radiologist is still making the decision. So you may have an algorithm that presents to the radiologist, okay, these are the images that I believe, there's a tumor present. And then the radiologist then makes a decision based on other information and other knowledge that the radiologist herself or himself has. And it doesn't, the AI algorithm also doesn't necessarily need to give a 0-1 label to the radiologist. It doesn't need to say, yes, I think there is a tumor, or no, I don't think there is. There could be a confidence score, for instance. And then for those images where there's a low confidence score, maybe the radiologist looks into it deeper, right? It's not, all for one, or, it's not one or the other. It is sort of a spectrum of options that are available. And depending on the context, you're anywhere along that spectrum.
Right. I guess it's the question of, should AI be an enabler or replace the radiologist? In this case, it sounds like it's more of an enabler than a replacement, at least for the time being. At some point in the future, it might replace, but at this point, and Julian, you also had your hand up. I'd love to hear from you on this.
Just to mention something, because I don't want the audience to feel that we have AI products on the shelf ready to be turn on, turn off, and then no explainability. Meaning today, in fairness, we are mostly on customized products, meaning all the different applications are on-demand products that are built by researchers, by consultants, on demand for a certain company or for a certain business process. So meaning explainability in that context, or controlling bias, is much more easy in the sense it's not a black box, meaning you have people really working, adapting, building a specific software, and so with a deep knowledge of this software. Meaning perhaps at one point we'll be at just on-the-shelf product where you can just turn and it's working, but we're still very, very far away, probably 5 to 10 years, at least for most applications. So just to mention that, because I don't want people to feel that, okay, AI is everywhere, you just buy an AI software, you download it on internet, you plug it on your data, and that's working. Not at all. That's not the way it works. And we need a lot of researchers like Nicky definitely to build this software. We worked a lot with Amy, Vector, Mila, and a lot of researchers, Ivado, and that's exactly why we need these researchers to build software today in the AI space.
Amazing. Thank you. Thank you for all the responses. There's 2 more questions from the audience. One is, what are the best resources to start and adapt skills for AI before we implement it into our current data systems? I'm not sure who'd like to take this one. Any volunteers from the panel? Maybe do you want to take this? Oh, Julian, you have your hand up. Please go ahead.
Yeah, no, sorry. No, the reason I'm raising my hand is with AI, that's typically what we try to do. So we are funding projects, as I say, but we totally recognize that a lot of people don't have at all maturity in AI. So what we have built aside of funding industry projects, we're also funding a lot of workforce development programs and training programs. And we think if you think about AI maturity today in organization, you have to begin definitely by thinking what is AI and what AI could do for your organization before even thinking about doing a product. Meaning, the normal sequence would be you think about AI, you understand what AI could do to your organization, you look at your processes, you think what kind of processes could be adapted or transformed leveraging AI. And then you begin to think about a project, you have a blueprint where you really look at your data, you look at and then only you invest in projects. So that's a logical sequence. I'm pretty sure Brigitte will say that also for Roche. But I mean, that's really the way you should think about doing it, not doing a project by itself, but really thinking before and really preparing your project.
Absolutely. And Brigitte, you have your hand up as well. Would you like to add to that?
You know what, I just wanted to, first of all, I completely agree with Julien. And I just wanted to add the context of talent development in this space. And we heard about it from our keynote speaker. And I think as we move into this space, at least, in my company, it is really important to be looking to hire talent with these skills and to help train. So the previous speaker, I thought she did a great job. She talked about the fact that it's about training and developing the skills and then hiring, and really for the talent we have, how do we increase those skills and then go look for the new skills. And I would just say for us, I think one of my biggest learnings is in the talent that we're looking for in the generations to come. We are looking for data scientists. We are looking for biostatisticians. We are looking for those who know how to do AI and research. And this is a space where Canada has an advantage. And we have smart, capable, talented people with these skills. And the question for us as an industry, as private sector companies, with our research institutions, with our universities, is how do we keep growing this talent? Because right now it's a competitive advantage. And my worry is when Europe keeps moving, I mean, we're even seeing Rwanda 2 months ago announcing an AI center of excellence to start leapfrogging some of their healthcare systems. So how do we make sure we stay competitive? And one way to do that is to really think about the skills and the talent and how we make sure that our talent is renowned around the world altogether. So it's a great question. I just thought I'd tweak that angle a little bit.
It's a really good point, Bridget. We do have a lot of great talent in Canada, with excellent universities and great research going on. So and the final question here from the audience is, I understand through work with NKAI, there are worldwide efforts, including legislation, to include an external, diverse/inclusive review of AI. What steps should organizations take for preparation for these diverse reviews? Who from the panel would like to take this question? Shahram, were you comfortable addressing that one?
Let me think about that question.
Sure. Nidhi, how about yourself?
That's on the regulations.
Is that something you're familiar with?
It's not something I'm super familiar with, but I can start that conversation. I think for companies, in order to determine how to go about the review, I think they need to have a diverse body themselves. They need to also reach out to stakeholders. Who's using their products? How are their products being used? And how does this impact them? I think that's really how they need to start that thought process. And then go about looking at how do these regulations and policies impact my stakeholders, my products, and so on.
And Bridget, you've raised your hand, so please go ahead and comment.
I did, and Nidhi has just really responded to what was on my mind. One of the things that I know we are looking at is the responsible use of artificial intelligence within the company and within our own platforms. And we've been working with 3 different organizations, AMI, Mila, and the Vector Institute. Back to your point, Nidhi, about partnerships and really consulting with other stakeholders, because for us, it is about closing that loop between regulatory policy, quality management, the technical development, the research development, and making sure that we're constantly thinking about all of the different elements to make our systems responsible, fair, to ensure that we've got good, strong data, but that we're, very ethical in its management, very responsible in its management. And I think we are, I can say that, learning a lot from our partners in this space. And I think bringing it back again to this is where I think we can learn from each other as corporations. We can learn from each other within healthcare. And I think this is where government could play a really strong role in bringing us together. We've had limited fora in these discussions in AI and health. And I think this is a space where government could play such a nice active role in helping us all learn and bring forward that sense of responsibility.
Absolutely. Yeah, thank you for that comment. Appreciate it. We have about 10 minutes left, and there are a number of really other great topics that we want to discuss. But maybe what I'll ask the panel is to tell us about the future trends in AI and impact to industries. I come from the privacy and security industry. I've been in this business in that field for over 15 years, and prior to starting this company, I worked for the 3rd largest bank in the world. We used AI to detect fraud in payment systems and things like that, and there's a lot of work being done in that area. But what I'm curious to see what other industries are doing, what are the trends coming up? Shahram, would you mind starting that conversation?
Yes, sure, Farshad. Good question. Actually, in addition to motion metrics, via Creative Destruction Lab, which I've been involved with for more than 6 years, I have invested in a number of ventures out of Canada and internationally, who in the AI space, in robotics, in financial sector, in healthcare, and all that. So I see this, as they say, we are in the fold number 32, 33 of technology. About every 1.5 years is doubling, right? If you take a thin paper and you fold it 50 times, that's the power of exponentials. You get to the sun, from less than a millimeter to the sun. And really, I think we are, and that's why, people like Elon Musk are warning us that as we go to the numbers 32, 33, 34, 35, the growth is going to be huge, and it has to be controlled. It has to be regulated to prevent problems. in our case, and primarily all the ventures that I've invested, a lot of focus on narrow AI, which, also Julian via superclusters, they are doing similar work on the supply chain side. So I am honestly, similar what Elon Musk says, I'm less worried about narrow AI. I think it's going to make life better. It's going to make mining safer, sustainable, and make our finances more secure, and all our interactions with the bank and all that is going to be better. On the AGI, artificial general intelligence and artificial superintelligence, that's the part I'm worried about, similar to those people. And I think it will be interesting to see, I would say, next 10 years, how this will unfold. Thanks, Farsha.
And Shahram, you pointed on something really important. Regulation, I think, is quite important in that field. We're fortunate that we live in Canada, and countries like ours, they have regulation, but unfortunately, we don't control the rest of the world. And my worry is that countries, not to be named, that don't have regulation, that are just treading ahead, in these waters without much consideration to some of those topics, would end up going places that would hurt the rest of us in the world. And that's something that needs to be discussed at the global level. I think it's quite important. Julian, you had your hand up. Please go ahead.
Well, by the way, Shahram, I'm very happy you talk about Creative Destruction Lab, because I'm managing also the Creative Destruction Lab in Montreal on AI and AI in supply chain. So if you want to be a mentor in Creative Destruction Lab in Montreal, that would be very nice. But saying that, I mean, what we see on the very operational field, so not talking about financial research, is projects initially were very company focused. So you had really one company working by itself on demand forecasting, pricing. So every aspect of its activity, and applying AI to its activity. What we foresee for the future is AI being applied to chains of companies working together. So with more ability to share data together, to share information, so you can, and in supply chain, that will be ultimately critical, because you want to follow a product from production to sales. And of course, that's involving multiple companies. Meaning, I was talking with Lockheed Martin the other day, that have 38,000 suppliers. So you need to work with these people at once. So what we see really is more willingness and more ability for people to share data. And I know it's not easy and there are a lot of communication, but more conscious about it will be more easy to share data in the coming years. And so to apply AI software to multiple data sets for multiple companies to improve globally a full ecosystem and not only a business from one company itself. So that's a huge tendency we see for the future.
Thank you very much for that. Yeah, and I know in my field, in security and privacy, there are algorithms that are being worked on, such as homomorphic encryption, which can be used to process data without knowing what the actual data is. And I know a lot of machine learning and AI really need to process that metadata. So those technologies will really help further that. Bridget, please go ahead.
Just to build on Julia's point and the point you just made, for me, when you look at future trends, I mean, we talked a little bit about some of the elements we're going to see in healthcare. Your point, both of your points about information and health data and how health data is shared. If we look at Canada, we are in our federation, we have so many different provincial structures and legislative avenues, and it will be important for us to understand how those different jurisdictions can share this information. To Julien's point, how do we do that in a safe way that respects provincial jurisdiction, but allows for that information to flow so that this technology can then really enable the decisions we need in healthcare. And I think apart from talent, which we've already talked about, I think the other piece when we're thinking about clinical research or we're thinking about clinical outcomes, Julien, you touched on it a bit, it's how do we scale globally out of Canada? Because right now they are relatively distinct projects that we're working on. And the real benefit for a global company is how do we help take the talent and the innovation from Canada and then globally scale it so that others can benefit from it as well. And I think that's a question we're going to have to tackle sooner rather than later. So when you ask about future, for me, that's not 10 years. That's like next week. What would the future hold and how could we do it?
That's good.
Awesome. And hopefully the future is not like the one they portrayed in Terminator, right? Where they robots take over the world and it all gets destroyed, right? We'd like a different future than that. We're all going to work together on that. So we have about 4 minutes until the end of the session. Are there any final words that you'd like to leave the audience with?
I'll start, I guess, with the order we go. So first of all, I really enjoyed this panel discussion. With Motion Metrics, we are Motion Metrics now as part of the We Are group, which is the new owner. We're excited in Vancouver. we are establishing a center of excellence on AI and machine vision. So 4 locations, 2 just beside universities, UBC and SFU, 1 in downtown, and we are building a state-of-the-art manufacturing facility, which should be ready in 3 months. So excited to be shipping these systems out of Canada, where AI was born, where sustainability is a key thing, and where mining is very important. So just 2 quick points regarding the comments earlier, and the question was asked. I would say in number of years, when I feel more secure sitting in an autonomous car, I will ask, who is analyzing my health image data? That is the time I'm like, okay, let's get human assistance, but I want to make sure I have an AI engine, maybe a very cheap app on my cell phone can help me do that. So I would be interested on that. And just one final comment on my side is, we just came out of pandemic. We talked quite a bit about health issues. Honestly, when you look at it, it wasn't a health problem, it was a prediction problem. We had a very small percentage with the issue. If we could have isolated and said, don't move, we didn't have that problem. But, that's where it got us. So there's a lot of positive things. Being a former CEO, I tend to be thinking positively. Thank you very much, Farsha.
Awesome. Any final, Bridget, Julien, Nidhi, any final words from you?
Yeah, I think on my end, just to pick up on that positivity element, it's a really interesting point he's just made, isn't it? I think, healthcare, if we're going to think about healthcare in the next 10 years, it is about how we are going to integrate, thoughtfully, responsibly integrate technology, digital, health, AI into our healthcare systems to help make it more efficient, more reliable, better outcomes, and better research. Absolutely. And I think for us, the opportunity as Canadians is to really take the excellence we have and understand how we can then scale it around the world. The life sciences sector strategies that we've seen, the different strategies we've seen from government, they're all great bases. It's now time to act, because other jurisdictions are acting. And if Canada wants to be in this game, and we have every reason to be in it because we're extremely good at it, it's about the future being now, not the future being in 10 years from now. So thank you. I learned a lot. So thank you for allowing me to participate.
Thank you, Bridget. Julien, how about some final words from you?
Yeah, well, I think if we think about a greener economy, AI will definitely help. If you think just about supply chain, that's all what I know. It's really doing more with less. And I think if we want to sustain a certain level of living and with spending less resources, AI will be absolutely key. So, of course, we need to control AI. We need to be sure to avoid all biases and issues on AI. But on the other side, it's also a tremendous opportunity we should use, because part of a better future also relies on our capability to use better resources we have. So.
Absolutely, 100% agreed. Thank you very much. And Nidhi, how about yourself?
Yeah, thank you. I'd like to close by saying that, AI, impacts many different aspects of our society. It's really not just one sector, it's many sectors, and it's, practically everything that we really do all day as a person. So I think that what that means is that we need to have conversations like this, conversations between different stakeholders, conversations between those who are building AI or those who are doing the research, those who are doing the training, those who are consumers, regulatory bodies, policymakers. I think we all need to have a conversation about how to move this forward. I don't think it can be just any one by itself. And that's what I'd like to close with. And I thank you for this opportunity, because these are exactly the type of conversations we should be having.
Excellent, excellent. Thank you. And yeah, in final words, I'd like to thank all of our panelists for this fantastic conversation. I know a lot more about AI now than I did before. And I'd like to thank all the attendees as well. And I hope you've been enjoying the sessions. And I'd like to welcome everyone to a health break after this. And with that said, have a wonderful rest of your day. And thank you once again.
Bye,
thank you, Farshad. Thanks, everyone. Bye-bye.